Good afternoon, everyone. My name is Xiaoqiang Guo. I come from the Southwest Petroleum University in China. I'm very happy to take part in the conference. Today, I will introduce my work about the three-dimensional flowed into state nonlinear vibration model of the 2-bit string in HPHT and high gas fields. Today, this is my contents. I will to introduce four parts. First, I will introduce the definition of the HPHT gas well. According to the US Code of the Federal Regulations, when the temperature definition, when the bottom of the well, the temperature is more than 1,115 centigrade, there is called the HP, and the urgent HP HPHT temperatures is the temperature of the wells is more than 1,077 centigrade. And also the player definition, when the bottom of the well, the player is more than 69 MPa, that is called the high player, and the urgent high player is the player is more than 1,155 MPa, and the definition of the well depth. The well depth is the deep is more than 4,500, and the urgent deep wells deep is the 16,000. And in the overall world, the distributed of the HPHT gas well is more than in China, US, UK, Gulf of Mexico, and Canada and Australia. And my research is focused on the South China Sea's HPHT gas resource. We can see this picture in the South China. There is more and more research gas resource in the HPHT well. About the northwest South China Sea is about the 56% of the total resource in HPHT gas well, and the south central South China Sea of the South China Sea, there is about the 33% of the total research. And also in the South China Sea, there where deep is more complex, because their directional well and horizontal well is more and more increased. And also the well deep average is 4,331 meter, and the player is more than 15.4 MPa, and the temperature is about 1,042 centigrade. Also, the production is more than 1.2 meters square a day. So the software in South China Sea is the typical HPHT and high yield gas well. Also, when the 2-bit high gas flowed in the 2-bit stream, there will cause the 2-bit stream's vibration according to the lateral vibration, also the longitudinal vibration. When the vibration is the linear vibration is occulted, there will cause the failure of the 2-bit stream. Mainly, the forms of the failure 2-bit stream is include three forms. First is the buckling deformation, and the second is flexion deformations and the vertical flexion. So next, our research for the HPHT nonlinear vibrations in the South China Sea is important. Next, I will introduce the three deformation FIV vibration model development in the three high gas well. First, we also in the South China Sea or all the world, the HPHT gas well is more and more used the horizon well or the derivation well. So the well inclined angle and atmosphere of the 2-bit stream is more and more important to establish the model of the 2-bit stream. So first, we use the qubit splenic interpolations method to calculate the inclined angles and azimuths. We can see the equals can express by this picture. Also, we according the equals, we can get the at any depths of the inclined angle and adverse at any depths. Next, we also know when the gas well is product, the bottom of the well and the top of the well, their well bone, the temperature and pressure in the well bone is changed at any depth. So we should to institute the calculation of the temperature and pressure. We used the gas state equation and heat transference series. We established the model of the calculation, model of the temperature and pressure model. This is the equation. And when also we know the temperature and the pressure in the well bone, next we will to introduce the three deformation FRNV's equation of the tube string, the finite element method, energy method, and Hamiltonian's principle are comprehensive used to establish the three deformation FRNV's model of the tube string in three high gas well. First, we can express the strength of the tube string by the first equations, and we put the equations into the total kinetic energy and the potential energy and the energy with the extraneous force. The T is the total kinetic energy, include the tubing and the fluid in the gas fluid in the tube string, and the U is the potential energy, and the W is the energy with the external force, including the tensile strength energy and the bonding strength energy. So we put into and simplify, we can totally get the equation of the tube vibration equation of the tube string. The first is established, is indicated the vibration of the X axis, and the second is the Y axis. The third is the Z axis, also is the longitudinal vibration. Also, we establish the vibration equation of the tube string. Next, we will to introduce the bounding condition of the model, because we should to establish to calculate the model. First, the bounding equations of the string, including the force of the tube string and the high speed load. The first, the contact load and friction force between the tube string can express by first equation, and the high speed flow impact load can express by second equation. This the alpha T and the phi T is the deformation of the tube string at any times for the tube string. Also, the bounding condition and the initial conditions of the tube string can expressed by the third equations. The third equation we also know that when the production the tube string upper of the tube string is the Parker, and the upper of the tube string is the tube handle, and the bottom of the tube string is Parker. There the tools, the action of the tools is get the tube string not to moving. So there is action at the fixed ends. Next, we will to introduce the calculation of the model to calculation the model. First, the cubic Hamilton's interpolaar functions is used to solve the linear fluid induced couple Kerr equation. This is the expressed of the displacement, and we put the displacement inefficiency of the displacement into the energy. We can get the total equations by the mb double dot plus c double dot 1 double dot and k d and the f equal f. And next, the components of the M. The M is the microfinite element, and the M is the Morse matrix. The C is the damping matrix, and the K is the stiffness matrix. And the components of this the matrix M, C, and K, the spatial of the components can expressed by this equation. M is ME, M1 to M4, M5, and C is C1 and C5. The K is K1 and K12. Because we also know the element method used to, but in the HPHT gas well, there will also the direction well or the horizon well. So we should do coordinate transformation. We coordinate angle transformation. We can get the coordinate transformations can expressed by this equation. And we use because the nonlinear factor of the 2-bit string, the model of 2-bit string is more and more complex and more and more. So if we want to calculate the model, there will more and more difficulty. So we should to use the Newton-Raphson method, combines inculator Newmark beta method. This is the scale, the solution float chart can express by this picture. Next, we can get according to Fortran language. We can type the code to calculate the vibration of the 2-bit string. So next, we will to introduce the results and discussion. We should to introduce the temperature, the 2-bit string, the vibration of 2-bit string. We use the HPHT gas well in South China Sea. We can see in the table, this is the parameters of the calculation. The parameter include the tubing casing and the temperature and the production and the player. This is the trajectory of the A3 direction well. We can see this is the typical direction well, and this is the schematic of the 2-bit string. And we can use the calculation of the temperature and the pressure. We can get the temperature and pressure can expressed by this picture. We can see at different depths of the 2-bit string, the pressure and the temperature is different, and the temperature is the linear changes, and the pressure is linear changes, and the temperature is the linear changes. And we also get at a different time of the 2-bit strings of the vibration trajectory. We can see we also calculated 15 seconds. So the 10 second, 20 second, 30 second, and 4 second, we can get the 2-bit string vibration. We can see the 2-bit string, the bottom of the 2-bit string, the lateral vibration is more and more serious, but at the bottom of the 2-bit string, there will more times is contact on the wear band. So the wear of the 2-bit string is more and more serious at this position, middle and bottom of the 2-bit string. This is the amplitude frequency response of the 2-bit string at different directions according to x-axis and y-axis and z-axis. We can see the x-axis and the y-axis is more complex, but the frequencies of the 2-bit string is more little, just about 1.08 around, and the z-axis, the frequency is about the 1.66 the 2-bit string, the main frequency. And also we can get the phase trajectory of the 2-bit string in different direction. First is the x-axis. We can see according to the 2-bit string, the contact of the tubing and casing, we can see the tubing string is more is not the quite is not the is more and more complex. Also more can see the charts, and also the X is more complex too, because it is contact with the casing, and this is the Z trajectory, the first trajectory also is not the is not the very, we can see the picture is not a trajectory, the trajectory of the tube string, the more and more complex in the ZX. So next we want to introduce the conclusions. The conclusions is can include the three parts. The first is in our work we are three dimensions nonlinear vibration model of the tube string in high pressure, temperature, and high gas where carded gas where were established using the macrofinite method, energy method, and Hamilton method. When second, because the nonlinear factor considered in the model is complex and in the solution is extremely difficult. So the SOC is use the language functions and cubital Hamilton functions to discrete the vibration equation, and use the incremental forms of the Newmark beta method and the Newton-Raphson method to solve the discrete control equation and realize the numerical solution of the three deformation FA and base model of the tube string in three high power gas where, and also thirdly, the vibration in the XY plane of the lowest part tube string is main occluded, and the tube string at this position is close to the case well. So in this position, the tube string is where cause the wear of the tube string. So when the atoms of the tube string change the above wears on set, the analysis of the tube string will not be accuracy if only consider the planned vibration of the tube string. So the three deformation is more and more supervaluous and effective than the two deformation binomial model. Thank you for my attention. Thank you, everyone.